as we transition into starting to think about direct current circuits, and we will find out what exactly is meant by direct current in just a little while, we have to start thinking about what is current. You've probably seen the term current around in reference to electricity, and you've of course also seen the term current used for water flow. So I want to just spend this video talking about what current is and what the units of it are. So conceptually, if you imagine we have a wire, okay, and there are some charges flowing down. Ignore what you think you know right now about what's actually moving. And we're going to say there's some positive charges moving down the wire. Okay? Well, if you think about water current is how fast the water is flowing. Okay? If we want to be a little bit more precise, it's not just the flow speed in meters per second, it's how much water is going by. So there's got to be something about the sort of volume per second as well. In fact, we talked about this earlier when we discussed flux. Current in a wire is, if we imagine sitting beside the wire someplace and watching how many charges flow past an imaginary line across it every second. Okay, so we watch this charge go, and maybe this charge go, and this charge go. Okay? If we count all those charges, that would be the current. The number of charges flowing past a point in second. So current is Q per T, charge per time. Okay. So it's a measure of just how much charge is flowing down the wire. Okay. We can get high current in two different ways, you'll notice. We can either have the particles, whatever's carrying the charges, move very, very quickly. And in most real wires, that doesn't really happen, it turns out. The charges hit so many roadblocks in regular wires that they stop so much. They don't really move that fast. Or we can just have lots and lots of charges moving. Okay, so current units-wise is measured in amperes, usually just called amps. And the symbol is a capital A, okay? 1 amp is 1 coulomb per second. Or if you prefer, this is like 6 times 10 to the 18th electrons going past every second. Which brings me to a whole nother point, which is what's actually flowing in a wire when we have a current. If we have a current this way, the symbol for current is I. What's actually going on, we talk about it as if it were the positive charges going to the right. But really, you and I both know that it's electrons that are free to move in most conductors, metals in particular. I think I've alluded in the past, there are some ways of making conductors where positive charges can move. Plasmas are one example, but we're not going to really think about those. What's really going on then is electrons are going to the left. But it turns out mathematically identical to positive charges going to the right. Ben Franklin, some 200 and something odd years ago, had to decide how to basically talk about the flow of quote-unquote current. He chose to go in the direction, one direction, okay, basically from what we call the positive to negative anodes, or not anodes, electrodes. But it turns out that he just guessed backwards, or at least for convenience sake, guessed backwards. Because it turns out the charge carriers were actually going the other direction. It's a pain in the ass, because we're always going to be thinking in our brains, well, the current's going that way, but the electrons are really going that way, so what way do I go? But remember, it's the direction positive charges would be moving, okay? All right. That's all I have on current. Next up, I'm going to discuss Ohm's law, and if you don't go on to that, I will see you in class, and have a great evening.